Let's write a second function that processes a list of numbers according to the data definition, the template, using the two new things in the template. We've added a make the natural recursive call, which again sort of fell out of, hey, what are the types of the things I have in my template and what are functions I could call on those? And this sort of what I'm going to be calling the inventory with value step. So we wrote the sum of a list of numbers. Let's go ahead and look at another one. How about just the length of a list of numbers? How many elements does the list contain? Okay, so I'm not going to use the word length because that's a built-in function already, but we'll see how to write it ourselves. So I'll call it myLength. And we can go and think about test cases pretty dang easily. What is myLength of, let's go here. MyLength of the empty list contains 0 elements. How about the list just const 4 empty list? There's 1 element in that list, 4. How about the list containing, so const 2 of const 4 empty list? There's 2 elements in there. Const 99 of some existing list with 2 elements. That gives us back a list with 3 elements. Think of const saying, hey, I take 1 item and an existing list and I tack that 1 item onto the front to get a slightly longer list. That's what const does for us. Yeah, I know it's a struct with 2 fields, but we're thinking now for lists, we're going to think of those, that as being a list that tacked 1 item onto an existing list onto the front. People sometimes ask, by the way, they say, hey, const 4 empty, shouldn't that be length 2? It contains 4 and it contains the empty list? No, just like the empty, oh, we got a little hazardous invader here. Just like we don't say that the empty list contains the empty list, and the empty list doesn't contain 1 item, the empty list contains 0 items. Hey, let's go ahead, hey, Cord, let's go ahead and take Snort and leave him go play downstairs, okay? Do you want to show Snort to my students? Bring Snort over here.
Why?
We have an urgent interruption here. So take here.
Can they even see them?
They can, not just my students, but my students who live in the future can see this. So hold up Snort, hold it up to the camera, hold it up to that green light so they can see Snort and how cool Snort is. Yeah, how is that for a Beanie Baby? Okay, so let's resume here. So remembering that the list contains numbers, not the empty list. That empty list was in some sense the sentinel saying, hey, there are no more things inside there to be contained. Okay, so we can come up with these test cases right away. Let me go ahead and put them on 2 lines to make the result a little bit stand out a little bit better. Okay, so how should we go ahead and write this function? Go ahead and try it. Go ahead and copy the template and flesh it out. So go ahead and pause. Okay. Yep, you did awesome. We took the template, changed the func4 list to be myLength, list of numbers. What is the return type? Realize, hey, it's a natural number. Put in a little purpose statement there. We'll go ahead and call it myLength, copy, double click, paste. Remember to rename, in the template, rename that recursive call as well. Okay, so we have a con with 2 variants here. Empty list, length of the empty list, always 0. Great, we have this here. So first of all, again, we're going to think about sort of the inventory with values again. I'm going to say, hey, for one of my test cases, I might take one of these typical test cases, or I might start from the beginning and work up either way. I'm going to go with a typical test case and say, hey, suppose that Alon is this thing here, okay? Oops, sorry, this one here, sorry, it's const 99. Const 99, const 2, const 4. The list containing 99, 2, and 4. What is first of Alon? 99. In fact, we'll go ahead and actually put this in here. So if Alon stands for this thing here, what is first of Alon in this case? 99. What is the rest of Alon? Oh, that's the list containing 2 and 4. Okay, so great. Copy, paste. Okay, what is the result of the recursive call? What is my length of rest of Alon? Well, clearly that should be 2. Okay, and that's the key I want you to do. I want you to stop there. I want you to say, hey, inventory part by parts. I have 99, I have 2. Those are the 2 things I have that the template is giving me. This and the result of the recursive call, and that's where my thinking starts. Okay. So, what do I want the answer to be? In this case, that was one of our test cases, our last test case. So, yeah, we want the answer to be 3. How do you combine 99 with 2 to get 3? Well, you don't really care that it's 99. You just take the 2 and add 1. Okay, so we don't actually use first of Alon in this example here. We simply take the result of the recursive call and add 1 to it. Okay, so that should go ahead and be correct here. Let me go ahead and run that. See, last step of the design recipe, watch our test cases pass. Oh, we have some problems. This is actually the next problem I'm going to work on. So yeah, 4 of the 25 tests failed. Really, those last 4 are for the next problem. So all of our tests pass. Okay. Here's what I do not want you thinking. I don't want you thinking, hey, I'm given from the template, I have 99 and I have const 2, const 4 empty. No, you don't have rest. The template does not give you rest of Alon. It gives you length of rest of Alon. That's where you start your thinking. And again, if you're queasy about, gosh, how does that work? This feels cheap. My length is calling my length, and I'm just going to assume it gives the right answer and builds my answer out of it. Well, again, work through it. I think the way to do it then is to say, look at my test cases. Hey, will it work on if I pass in my length of empty? Yeah, I know I'll get the right answer there. And if I pass in const 4 empty, well, I'm given 4 and length of the empty list, which I know is correctly 0. So I'm given 4 and 0, and I just ignored the 4. I added 1 to the 0 and got 1. And that was the correct length. So yeah, I really will pass this test case. And then the part where, it's the next one. You're like, well, maybe it works there, but you only recur once. But how does this next part work? Again, I'm given first. So if I'm given this entire list, I have the first, 2. I have not const of 4 empty, but length of const of 4 empty. So I'm given 1. Okay, so I have the first number and then I have a 1. How do I put those together to get my overall answer? Oh, I add 1 onto that. And we were like, hey, well, why was length of const of 4 empty 1? Oh, we just worked through that case, so we believe that. And so when you work up step by step, I never think of it as unrolling all the recursion. When I'm writing my function, I simply say, hey, I will have this answer from the design recipe, from the template, and I will use it. I'm guaranteed to get the correct sub-answer. I claim that recursive call should make you no more queasy than making the example of the data made you queasy. If you were like, hey, how is const 99, const 2, const 4 empty? How is that really a list? Const 99, const I'm happy with, the construct in 99, but then I'm making another const that's contained inside this const? Well, yeah. And the computation mirrors that structure, follows the shape of the data. So, one more example. Let's go ahead and look at contains 93. Okay. Taking a list of numbers, does the list contain 93? Okay. Certainly you can generalize this to contains where you pass in the target you're looking for. Feel free to do that. Go ahead and pause. I want you to, the list intro before file contains test cases of taking care of those for you, but I think writing one down really does help. People do better if they actually write down 1 or 2 more test cases themselves. follow the template. Answer these inventory with values questions to yourself. Write them down and see if you can get working code for contains 93. Go, by which I mean pause. I mean go do the other thing. Okay. Good, I'm glad you got it. Again, I'll just walk through the steps as I see them. Contains 93, I'm going to copy and paste the template. That's why we put that template here. Copy, paste, and contains 93. Put that right there. Okay, so this is what the template gives me. Went through, if you look at the test cases I wrote, I think it looks like, oh gosh, I made like 8 test cases there. Isn't that a lot? Isn't that a bit excessive? Well, I want to test the empty list. I want to test a list of length 1 that contains 93 and a list of length 1 that doesn't. So neither of these next two they're both really exercising different things. Then for list of length 2, I want one where the rest of the list contains 93 and also a list where the rest of, an example where the rest of the list doesn't contain 93. And if the rest of the list doesn't contain 93, well, the first thing may or may not be 93, okay? And then I have examples where, yeah, I want to even do that. I have a longer list that contain 93, but not at the very end. And I have a longer list that doesn't contain 93. So, okay. So yeah, all these tests, I think, are actually testing different things there. So let's go ahead and work this out. Contains 93. Empty. Does the empty list contain 93? Well, we saw by our first test case, no, doesn't contain the element 93. Okay. Here's a question for you. Does the empty list contain the empty list? The answer is no. The empty list is empty. It doesn't contain anything. Const of Alon, we're going to be given the first number in the list and the result of whether or not the rest of the list contains 93. Stop there. So let's go ahead and look at this inventory with values here. And I'm going to go and look at Alon stands for this thing here. I'll make it 93. How's that? What is the first of the rest in that? First of Alon in that case would be 93. What is rest of Alon? It will be blah, blah, blah. What is... Oops. What is contains 93 of rest of Alon? What is contains... If Alon is this particular list, what is contains 93 of rest of Alon? And if you said something like const blah, 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 no. Hey, remember we put the signature for our function there? That was one of the steps of the design recipe. And one important thing is, hey, what is, if I call contains 93 on some list, what will I get back? A Boolean. So I know that I have, first is a number, the result of the recursive call will be a Boolean. So I have 93 and the Boolean false. Okay. And what should the answer be? True. Okay. So how did I put together 93 and false to get true? Okay. Okay. So we need to put these together. Now, again, we also think of the pieces of our recipe. Hey, what type is this? It's going to be a number. What things might we call on it? What are some functions? Might call plus, might call greater than. Hey, I'm probably going to call are you equal to 93? That seems like a reasonable thing I'll want to call in this thing here. Okay, so I'm going to be given from first, I'm like, hey, check if it's equal to 93. Okay, and then this here was another Boolean. So actually I'm down to having 2 Booleans. Okay, and now we can sort of see that, yeah, if the template just said 93, I'm like, hey, pretty soon I'll convert that 93 into a true. And really I had true and false came together to say true. And what's the general rule for that? Well, gosh, if they are equal, then the answer will be true. So I guess I could do this. If that first part is true, then the answer is true. Otherwise, the answer is, gosh, well, what if that part was true? My overall answer should be true. If that part is false and I didn't have 93 at the first, then my whole answer should be false. Yeah, I guess this will do it. I can go ahead and run this, run my test cases, and see if they pass. All 25 tests pass. I'll point out, here's a separate thing. Well, let me first again emphasize the important part is, hey, don't think about, I have rest available and I need to somehow iterate down that list or do whatever. The template has done the list processing for you, okay? That natural recursive call, that is the list processing. We have done our loop, if you want to put it that way. Well, it's not quite a loop, but we have the answer already. You don't need to further process the rest of the list. We'll already process the rest of the list by making that recursive call on that. Okay, so don't feel like when writing an exam or writing a homework, like, okay, I pulled out the first, I pulled out the rest. Gosh, how am I going to loop through the rest of the list and keep track of a Boolean and update it to be true or false or something like that? No, this is a new approach, and it's going to simplify things. You just have you have the result of the recursive call. How do you put together those two pieces of information? Now, admittedly, there will be times in life where it gets tougher, where the answer to the overall question does not simply rely on the answer to the sub-question, the answer on the sub-list, if you will. So sometimes making the recursive call to rest and knowing the first is not enough to give you the answer to the overall problem. But those cases are actually more of an exception than a rule. Okay, so yeah, go ahead, and that's why the template suggested, hey, think about putting in the recursive call. So, okay, I'll finish with a little realization that if you ever have an if statement where one of the branches is return the literal true or return the literal false, probably there's a better expression than if to do that for you. Okay, in particular, and this is true in Java and Racket and Excel or JavaScript, whatever. If I go ahead and I have, at some point we said that, hey, I had a Boolean here and a Boolean here. How can I put those together? By the way, you can think about if I flip those two Booleans to my if expression, would that still work? Really, I had two Booleans, and what if they were both false? The first thing was not equal to 93, and 93 was not contained in the rest of the list. Well, then my answer should be false. What if one of them is true? Actually, if either one is true, we should be returning true. What if they're both true? I didn't actually have a test case for that. What if they are both true? The very first thing in the list is 93, and 93 is contained in the rest of the list. So it's contained more than once. Well, clearly the list still contains 93. So, yeah, did you want to see a truth table that says, hey, if you have false and false, the answer should be false, but otherwise, if the first thing or the second thing is true, or both, the answer should be true? Yeah, that was the function or, right? So actually we can go ahead and, we don't need that literal true in there, we can just go ahead and say this like so. Gosh, is that really going to be correct? Let's run our test cases and find out. Seems to work. By the way, I might go back and say, gosh, I now realize I should have had another test case where 93 was at the first and was in the rest of the list, to make sure that neither of these, turns out both versions handle that correctly, but I didn't actually test it, and I can imagine somebody else's code failing that situation somehow. Okay, awesome. You know how to take a list of numbers, or really could be a list of strings or a list of anything, and process it according to the natural shape of the data, according to that data definition, and get answers back. The next step we're going to talk about is just variations on this, nothing new, nothing fundamentally different. We're going to say, hey, what if the answer you want to give back is itself another list?